Hi, Zarina. I really liked your post about the one sample Z-test, that tests whether the sample mean is significantly different than a population mean. The only problem with this test is you have to know a mean of a population. That's not easy to find sometimes. Sometimes you have to use standardized tests, and there aren't too many of those around. So I always wanted to know, should I be taking Prevagen to pass statistics? You know, Prevagen is a memory booster for old folks. And so I was just wondering, I wonder if that would help me out here. And so I'd like to do a test, if you don't mind. And I would like to do a one sample Z-test. Now the problem is, do I have a standard deviation of a known population? And how am I going to figure that out? How am I going to measure that? How am I going to measure whether this medication or whatever it is effective? And so I would have to come up with something that already has a known standard deviation. And so I was thinking maybe we could do the memory test that Donald Trump did. Like, what was it? Person, woman, man, TV. I think that's right. I think I need Prevagen. But anyway, that wouldn't work because I think only one guy took it. You need 30. So maybe we could do something that is known, take some test that does have a population standard deviation, and that is just a regular IQ test. So for some population, or it's been measured, or it's in our book anyway, that the mean is known and it's 100. And it even has a standard deviation, a population standard deviation of 15. So we're all set. We have what we need. We have population population known mean and standard deviation. And we'll do a sample more than 30. So we can do our Z-test, one sample Z-test. But you still have to go through all those steps, and there are 5 of those. So first you will define your null and your alternative. My null hypothesis will be that the IQ will be 100 after taking Prevagen, and my alternative will be it will not be 100 after taking Prevagen. My second step is just to define my alpha, which, for good researchers, it's going to be 0.05. Then I'm going to state my decision rule. So it will be a two-tailed test. So my two ends will be 2.5% each end to add up to 5%. And then I will do and so 95% are in the middle there. Then I will calculate that great big formula. And first I have to look in the table to see where my critical value is. And I'll get my critical value at 1.96, okay? Because that's pretty standard you got 95 in the middle, you got 2.5 on one end and 2.5 on the other end. You look up on the Z table and you get your critical value, and that's 1.96 or minus 1.96. And so before I do my calculation, I will know that if my Z number at the end will be more than 1.96 or less than minus 1.96, I can take Prevagen because I can reject the null hypothesis. So I do that in a computer, and I state my results, and lo and behold, my number is something big, more than 1.96. So I will state my conclusion. I may reject the null hypothesis, and I will take Prevagen. Except that I just moved out of the country, and ain't no Prevagen here, so I'm going to flunk. But anyway, I enjoyed your post, and I will see you in cyberspace. Thank you.